Let's talk about the bisection method. So this is a numerical algorithm, and this will be kind of the start of numerical methodology. This will also give us a chance to work with Excel as well as MATLAB. So let's get going. What is the bisection method? Well, it's a way of solving a problem with iterated cuts. Okay, so then this will allow us to find a solution to a problem by using repeated cuts. What is the process? Well, it's an iterative process. Here, let me go see if I have a picture. Hold on. There we go. So what is the bisection method? It allows us to try to find this zero by guessing one end that's above the axis, one end that's below the axis. You find the midpoint of the two, and then you do it again. Okay? So the idea is that if I cut enough times, I'll more or less land on the answer. So it's an iterative process, meaning that it goes over and over, and the new output is going to be a new input. And it allows you to decide how accurate you want your answer and then solve it. You actually have one of these built into your TI calculator. So if you've ever used a solver in your calculator, that's what it's doing. So what we're going to do is we're going to go ahead and make this thing. How does it work? Well, we input these values, the two endpoints, how accurate we want to be, how many times we want to try to cut it, the function, and then we start counting. We check to see if we're above and below the axis by multiplying the two y values. If we have one positive and one negative, then we'll be negative. If we're not, then something's wrong, and then we just output an end. We say, hey, it didn't work. If it does work, we go ahead and cut it in half and decide on which, and then we decide, is that the solution? If not, which side are we on? If we're on the same side as A, then we're going to replace A. If we're on the same side as B, then we replace B. And then at that point, we check to see if we've cut too many times. If we hadn't, then we do this again until we've cut enough. And when we have a solution. So we have a pseudocode. So we need to go find a pseudocode. Where can we get it? Well, we can find it from Wikipedia. There's a old Burgess book. It says numerical methods. That's really kind of the king of this world. And that has it in it. And there's a whole bunch of these. This is going to be a really basic one, so you'll find a lot of stuff online. I encourage you not to download a MATLAB code, but rather to code it yourself as we go through. So my first question is, what theorem is this based on? Okay, now think about this. What theorem is this based on? Go.